All right, picking up on a video segment 2 for the periodic table. Left off talking about horizontal rows. Row going left to right is called a period, and it's called a period because it has periodic properties, which means it's something that repeats itself over and over again. As you go left to right, you have metals on the left, to non-metals on the right. Each row of the periodic table does that. When you look at a vertical column, what's going up and down there called groups or families. Families because they will share similar physical and chemical properties. Um, uh, Most things in the same column end up acting the same way is a good way to put it. Um, Second objective we wanted to look at were the three main classes of elements. Those are metals, nonmetals, and metalloids. Metals are something we talked about, metals and nonmetals, both in chapter 3, how they are ductile, which means they can be drawn into wire. They're malleable, which means they can be bent without breaking. They have a luster, which means they're shiny. They are good conductors of heat and electricity, whereas nonmetals are basically just the opposite. Brittle, which means they break. They're non-lustrous, which means they're dull. They're poor conductors of heat and electricity, and so on. And your third category is going to be those with the metalloids. And metalloids are going to have properties that are intermediate. They're between both metals and nonmetals. In fact, sometimes they can act as a metal, and sometimes they will act and have properties that are more like a nonmetal. And it's what allows metalloids to be very versatile. If we look at the periodic table, basically you have the atomic numbers usually going to be written on top. If you remember, it's a number of protons. Your average atomic mass, and why it's a decimal is going to end up being because of the fact that it's an average of all naturally occurring isotopes. And then you'll always have the symbol and name. These electrons, not all periodic tables have the electrons in the upper right-hand corner of what energy level and how many electrons there would be in each one. Naming of groups. Group 1, the first column is called Group 1A. It's the alkali metals. Alkali metals will form a base when reacting with water. They are very reactive. They do not exist in nature by themselves. They're always reacted with something and forming a compound. Group 2A, the second column, is going to be called the alkaline earth metals. Again, they're also going to form bases. These are going to be much more readily found on the earth, hence the name earth metals, as they come. Then you have a big gap in there as we look at that we call transition metals that end up doing a lot of different things. And then the first couple of Group A elements of 3, 4, 5, and 6 don't really have names to them because they exist as both metals and nonmetals. By the time you get to Group 7A, which is going to be the one almost to the end on the right, it's the second to the last column. Those are called the halogen, which means they're salt forming. They're going to be the most reactive of all nonmetals. And if you basically break those things into 4 different groups, you have noble gases, which are unreactive. It's what every element basically strives to be. They're stable, and they are on the far right hand of the periodic table. Representative elements are those A groups we just talked about, transition metals, the ones in the middle, and the inner transitions on the bottom. So as you look here, here's our groups 1A and 2A, group 7A, those halogens, and then the noble gases, transition metals in the middle, and then your inner transitions at the bottom. As far as electron configurations, why they have the same chemical properties is because they all end in the same electron configuration. Not all the numbers in between, but look at the endings. S1, 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 S1 means they have one electron in the s orbital. And that's why they all act the same.